Hello, I welcome you all to your own channel MSK Learning. Now in this video we will discuss the Taylor's theorem, right? So Taylor's theorem is what? If any function AB belongs to real number such that f n minus 1 is continuous on closed interval AB and f n minus 1 is derivable on open interval a comma b, or f to the power n exists on a AB and one p belongs to real number z, then there exists a point c belongs to AB such that we can say f of b is equal to f of a plus b minus a by 1 factorial of f dash of a, means differentiation of f, plus b minus a whole square by 2 factorial plus f double dash of a, it is double differentiation, plus so on, so b minus a to the power n minus 1 by n minus 1 factorial f to the power n minus 1 into a plus rn. That is n minus 1 is nothing but that is means how many differentiation you have, right? That is how many step you have to take, either 2 terms or 3 terms, right? If the function is given, any function is given, and then you have to verify the Taylor's theorem, right? And then it is they are asking that you have to verify up to the 2 step, right? Then that n is equal to 2 means you have to differentiate, double differentiation will be there, means your equation will be up to here. If they will ask that up to 3 terms right now, that means n is equal to 3, then you have to 3 into, means 3 times you have to differentiate, that is f triple 3 of a, right? So and so that is n minus 1 is that only. Then there is a one number Rn is this, that is b minus a to the power p, b minus c to the power n minus p, f of f to the power n of c by n minus 1 factorial of p, right? So there are the various method we can use by which we can verify the Taylor's theorem, like we can use the Lagrange's theorem, we can use the Cauchy's, all those things right now. So here we have the one problem on the screen, that verify the Taylor's theorem for f of x is equal to 1 minus x to the power 5 by 2 with Lagrange's form of remainder up to 2 terms in the interval of 0 comma 1. So one function is given, that is the polynomial function 1 minus x to the power 5 by 2, and they are asking that you have to verify with Lagrange's form of remainder such that this is what you have, a remainder is there, right? So Lagrange's form of remainder is what we will discuss just now, that up to 2 terms you have to use right now. So now that we can start, first of all I will tell you that what is the Lagrange's form of remainders, right? So here we go that Lagrange's form of remainder, right? Form of remainder, right? So Lagrange's form of remainder is what, that you can say put p is equal to n, right? Then we have a Lagrange's form of remainder Rn is equal to x to the power of n, right, by n factorial, right, into f to the power of n into theta of x. So this is the Lagrange's form of remainder, right? So this remainder, whatever the remainder we have discussed just now, this is the Taylor's theorem, right? So this remainder will be varied up to, means it's depend on the which form of remainder they are asking. So in this particular problem they are asking to use the Lagrange's remainder. So Lagrange's remainder is this, x to the power n by n factorial f to the power n of theta x. So here n is nothing but the number of terms. So in that question it is mentioned that up to 2 terms we have to verify, right? So it means n is equal to 2, it is what, x square by 2 factorial f double dash of 2 into theta x will be there, all right? So now we'll start here. That you have a given is what, so here we go, yes, sorry. So here this is the solution for that problem, that given f of x is equal to 1 minus x to the power of 5 by 2, right? And it is belongs from 0 to 1, that is this is a b. So a is 0 and b is 1, right? So as we have to, first we have to check whether it is fx is continuous or differentiable not, right now. So we can say that first we have a f of x, these are the polynomials, so it is the continuous as well as differentiable at a closed interval and the open interval 0 comma 1, right? So f of x, and you can say f dash of x, right, is continuous in closed interval 0 comma 1, right? Second condition, second is what, that is f of x, then you have to differentiate up to what, double differentiation. Why? Because two terms they are asking. So f double dash of x, right, is derivable in open interval 0 comma 1, right? So that f of x is satisfy the condition of Taylor's theorem, right? Now, so there exists a point C in the Lagrange's form of remainder, right? So now we can say f of x satisfy this statement, you can write, right? So why? Because step marking, they will give you the marks in the exam, right? So f of x satisfy the condition of Taylor's theorem, right? Two condition just now we have see, right, Taylor's theorem. So we can say there exists a point so consider the Taylor's theorem with Lagrange's form of remainder, right? Now, so we can say that consider Taylor's theorem with Lagrange's form of remainder, right? Form of remainder, right? So Lagrange's form of remainder is what, that is here we can say f of x is equal to f of 0, right, plus x f dash of 0 plus x square by 2 factorial, right, f double dash of this remainder is what, remainder is nothing but the theta of x we will take, right? So here this is the Lagrange's form of remainder we have to take, that is Taylor with Lagrange. So this is up to here you can say it is the Taylor's theorem, right? And this is the Lagrange's form of remainder. Got it? Why? Because we are double differentiation we are using, it is mentioned in the question that up to the two terms only, right? So here you have a that you can continue this with theta belongs to 0 to 1, means that theta is up from 0 to 1, minimum range is 0 to 1, right? So now we can say put n is equal to p is equal to 2, right, and a is equal to 0, right, x is equal to 1, right? Now, so f of x is equal to what we have, that f of x is equal to, we can say 1 minus x to the power of 5 by 2, right? So that is nothing but f of 0 you can get, means 1 minus 0, so it is what, 1 only, right? Similarly we have to find out the differentiate this function, that is f of x is equal to this, right? So but first differentiation you can say f dash of x is equal to what, 5 by 2, right, into 1 minus x to the power 5 by 2 minus 1. So 5 by 2 minus 1 is nothing but the 3 by 2, right? So again we can find that f dash of 0 is equal to what, put 0, x is equal to 0, so this will be 1, right, 5 by 2, okay, am I right? F dash of x is equal to five by 2 nx to the power n minus 1, right? So 5 by 2 minus 1, that is right. Okay, so then we can find that f double dash of x, right? So means double differentiate that function, so it is what, 3 by 2 into 5 by 2 will be the 15 by 4, okay? So it is the 15 by 4 into 1 minus x, 3 by 2 minus 1, right? So it is 1 by 2, so this will be 1 by 2, and then we have to find out this f double dash we don't find at 0, that is theta of x you can say, right? Now so this is what you have a, that here we go, that f double dash of theta of x is equal to 15 by 4, right, into 1 minus x is equal to theta of x you will put, right, theta of x to the power of half, right? So on simplification, that is f of theta is equal to what, f double dash of theta is equal to 15 by 4, right, into 1 minus theta, is it or not, whole power 1 by 2. So that all the values we got. Again we need to find out the f of 1, right? So why? Because that f of 1 is equal to what? When you put in any, that is, I'll show you that f of x is equal to what? 1 minus x to the power 5 by 2. So x is equal to 1, right? So this is 1 minus 1 will be 0. So that means f of 1 will be nothing but the 0 we have, right? So all the values we got, right? Now simply we can say from that equation this, right, whatever the Taylor's theorem we have written with Lagrange's form, let's say this equation as a 1, right? So from the equation 1 with these values we can get the theta values, right? Now so now we can say that from 1, right? So from 1, what is that? F of x is equal to, again I'll show you that f of 0 plus x f dash of 0 plus x squared by 2 factorial f double dash. F of 0 just now you calculated, right? That is f of 0 is nothing but a 1. X f dash of 0 is what? X is x only, right? That is x is equal to 1, right? F dash of 0 we calculated 5 by 2, and x squared by 2 means 1 by 2, right? And plus f double dash of theta x we got, that is 1 minus theta into to the power 1 by 2 into 15 by 4, right? So we will substitute and get this. So here we go. So it is what? 1 plus 1 into 5 by 2, right, plus this is 1 by 2 factorial, okay, into 15 by 4 into 1 minus theta whole power 1 by 2. All right, so you got this. Again we can say that is f of 0, f of x, right? So f of x is equal to what? That is f of x is nothing but x is equal to 1, right? So we can say this is equal to what? 0, right? So 0 is equal to 1 plus 5 by 2, all right, plus 1 by 2 factorial is 2 only, so we can say 15 by 15 by 8, right, into 1 minus theta whole power half, right? So when you simplify right now, so on simplification we'll get some value of theta, right? So here you copy, and again I'll show you that how it came, right? So this equation will be nothing but you have a 0 is equal to 1 plus 5 by 2 plus 15 by 8 into 1 minus theta whole power half, right? So this is what you bring this side, that is minus 1 minus 5 by 2, right, is equal to 15 by 8 into 1 minus theta whole power half, right? So this is what you can get. This is the 2, right? Minus 2 minus 5 is equal to 15 by 8 into 1 minus theta whole power half. So this is minus 7 by 2 is equal to 15 by 8, right, into 1 minus theta whole power half, right? So this you can do, 2 2s are 4, right? So, minus 28 by 15 is equal to 1 minus theta whole power half, right? So this will come to this side. So it is what you got some values, right? So on simplification theta is equal to, you have a 9 by 25, right? Or you can say that is equal to 0.36. So now you need to check whatever the theta value we got, whether it is comes under the 0 to 1 or not. So it is actually, we can say, therefore the theta lies between 0 and 1, right? So hence the Taylor's theorem is verified. So hence Taylor's theorem is verified. All right, so this is how you will do the problem. Thank you.